Hello there. The day has come to discuss with you the solution of the problem that my wife presented to me about a week ago. She showed me this box with 2 eggs and she says, "Walter, I know for sure that one is boiled, but I forgot which is which. Can you tell me?" Within 5 seconds, I told her which one was boiled and which one was not. And she was very impressed. And the problem that you have to solve is, can you do the same? Can you tell me, using a method which takes less than 5 seconds, uniquely tell the boiled one from the unboiled one? Many of you have a reasonably accurate or close to accurate solution. The ones who have an exact solution, the one that I prefer, those I didn't post. My apologies, but see that as a compliment, because I didn't want everyone to see that perfect solution. Some suggest you take a flashlight and you shine through the egg and then you look at the egg. Indeed, there is a light glow, clearly light inside the unboiled one, absolutely not inside the boiled one. So that certainly is a way to do it, but there's no way you can do that in 5 seconds, apart from the fact that when I solved that problem for my wife within 5 seconds, I didn't have a flashlight at hand. Then there were people with solutions to shake the egg. And then as I shake it, you can feel the difference between boiled and unboiled, and you can also hear the sloshing of an unboiled one. I tried that, didn't work for me, maybe it works for you, didn't work for me. And I wonder whether you can do that in less than 5 seconds, even if it were true. Then there are many who say the boiled one weighs more than the unboiled one, or many say the boiled one weighs less than the unboiled one. Now, first of all, let's take an egg which is unboiled and let's weigh it. Boil it, dry it, and weigh it again. You will see, with as accurately as you possibly can weigh it, which for me is 1/10 of a gram, the two weigh exactly the same. And that's what you expect, because nothing really can escape from inside the unboiled one to the outside. So therefore, you wonder whether perhaps, as some of you suggest, the chemical reactions in the unboiled one would produce some heat, and that heat surely can escape, of course, in which case the boiled one would weigh less. Well, for those of you who are familiar with special relativity, E equals mc squared, keep in mind that chemical reactions in general generate several electron volts, and keep in mind that the mass equivalent of protons and neutrons is about 1 billion electron volts. So surely, if there were a chemical reaction that was exotherm, then you should be able to convince yourself that the heat loss would be less than 100 millionths of a percent. And if the reaction were endotherm, there would be an increase in mass in the boiled egg, which would also be less than 100 of a millionth of a percent. So forget the weighting thing. And then many of you have that a boiled egg sinks and a raw egg floats. Well, I wonder where you get that idea. If you take an unboiled egg, it has a certain mean density, which of course is exactly the same as the same egg when you boil it. In fact, all eggs, regardless of whether they are boiled or unboiled, would have approximately the same density. And you can look that up on the web. It's about 1.03. So 3% higher than water. So clearly all unboiled and all boiled eggs will sink in water. And you can try that. So that is a dead issue. Now, oh, by the way, what is interesting, that if you take salt water, which has a density of 1.02, both eggs will still sink. But if the salt water has a density of 1.04, then both eggs, boiled and unboiled, will float. Then there was a very interesting solution. People say, roll down both eggs from an incline, a tilted plank. And then they say the unboiled one will go much slower than the boiled one. That is true, but without exception, all of you have the wrong explanation. All of you argue that due to the difference in moment of inertia. I will refer you to my lecture 24 of Ada 1, in which I thoroughly discuss the theory of rolling objects and I demonstrate them. You may see there that I roll solid cylinders off the incline with very, very different moments of inertia. Different radii, different mass, different moment of inertia, different length. All roll down the incline in exactly the same time. So the notion that the moment of inertia is the deciding factor of how fast someone rolls is wrong. So that won't work. However, it is true that the unboiled one goes much slower. But for very different reasons, and I will explain shortly what those reasons are. All right. Another very interesting is the following. Let me make sure that I have my note right. Yeah. Well, let me first show you the one that I really prefer. The one that I used for my wife that is absolutely conclusive. I pick one of those eggs and I spin them. If they spin like crazy, it's the boiled one. If they hesitate, if they don't want to be spun, if they spin up very slowly, then it's the unboiled one. And I will give you the explanation for that too. So I pick this one, say, and I rotate it. Rotates happily and like crazy. Now I take this one, that must be, by the way, this one therefore must be the boiled one, right? So this one then must be, by default, be the unboiled one. Watch it. See, you can hardly get it going. Look at it. It fights being rotated. And why is that? The reason is that the liquid cannot instantaneously start to rotate. Think about the liquid which is touching the shell. That needs some time to get rotating, and that means there must be friction then between the liquid and the shell. And that friction causes heat. So the viscosity of the liquid throughout the unboiled egg will almost everywhere in the egg dissipate energy. It dissipates energy that I put in there when I rotate it. And that's dissipated in terms of the heat due to the viscous forces. After a while, all the liquid rotates, and then, of course, the unboiled one will rotate. But most of the energy has already been dissipated into heat. So here you see this once more. I really give it the same twist that I gave the boiled one. Notice that it doesn't want to go, and if it does go finally, it goes much slower. It takes about half a second for the liquid to absorb most of the energy in terms of heat. And then it goes, and then it rotates slowly with a near constant speed. But ultimately, of course, it will stop. I'll try again. You see, it doesn't want to go. All right, so that's pretty convincing. That's the way I did it for my wife. And that I didn't even, when I did it for my wife, I picked one of the two, and the one that I picked was rotating like crazy. I can easily do that in less than 5 seconds. And then, of course, I told her that the other one was clearly unboiled. I'll show you that I can do it in less than 5 seconds. Are you ready? 3, 2, 1, 0. Here I go. 1, 2, 3, 4. Within 4 seconds I got it. All right. Another very interesting and correct solution is you take the egg and you spin it. And then you stop it. You spin it and you stop it. And then you take your finger off after you stopped it. Rotate, stop it, take your finger off. It stops rotating. This is the boiled one, remember? If you do that with the unboiled one, keep in mind that the liquid, after a while, starts spinning with the egg. When you stop the shell, however, the liquid inside doesn't stop instantaneously. Still keeps rotating a little. So therefore, if you spin this one, put your finger on it and take it off. After you take it off, it will rotate again a little bit in the same direction. So let's do that. You see? I will do it once more. Stop it. I try to show you a more convincing, and then it does. So I stopped it with my finger, and then it rotates again. So that's certainly a correct solution. The question, however, is whether that would be a valid solution. That's a very different story, of course. Valid in the sense, can you really do that in 5 seconds? I don't know. Okay, well, let me put the unboiled one back here. So we have here a boiled one and here an unboiled one. So the key is that the unboiled one refuses to rotate because energy is dissipated inside. So when you roll it down a slope, that is why the unboiled one rotates slower, because energy is dissipated. It has nothing to do with moments of inertia. There is a very interesting phenomenon, and that is when you take a boiled egg and you rotate it and you do it fast enough, then it will change like this. So it starts rotating first. This is the main axis, and then if you do it very, very fast, it will rotate like this. It's an interesting phenomenon. I demonstrate that in one of my 802 lectures, number 18. I cannot demonstrate it to you here for 2 reasons. It doesn't work on this table, but it does work on my kitchen sink. However, I need both hands because you have to spin it with an enormous amount of energy for this to happen. And that amount of energy I can only put in with both hands. But I need one hand to hold the camera, so I cannot show it. But it's very easy, believe me. If you try a boiled egg and you do it on a different surfaces and you use both hands and you rotate it like crazy, it will indeed stand up and rotate in a way that you would not expect. All right, when then there is a final solution that people suggest, which I thought was really a joke, and so I will treat it as a joke, and that is, they say a boiled egg feels softer than an unboiled egg. So here's the boiled one. Well, doesn't feel soft to me. Some others say, no, the unboiled one feels softer. Well, let me take the unboiled one. Oh my God! They were right! An unboiled one feels much softer. Have a nice day, and see you, and take care.